Assalamualaikum warahmatullahi wabarakatuh and good day. My name is Mohd Faisal bin Hushim from Center of Automotive and Powertrain Technology, Universiti Tun Hussein on Malaysia. So today I will present my study with the title of Impact of Aggressive Driving Behaviour to Vehicle Fuel Consumption and Tailpipe Emission. For the research background of this study, as we know, the interaction between people and transport which affects fuel consumption and tailpipe emission is called as driver behavior. The driver behavior study involves three major components, namely the driver, vehicle, and environment. The vehicle and environment components are considered as physical factor, while the driver component falls under psychological factor. Among the physical factors, under the two components that influence the fuel consumption and tailpipe emission of vehicles are highway traffic operations, pavement conditions, highway design, type of vehicles, number of highway vehicles, and the mileage covered by the vehicles. Meanwhile, the driver component is a complex factor which changes constantly and is unpredictable. Hence, it's very hard to translate a driver's behavior accurately due to the socio-demographic difference, preference, belief, attitude, self-awareness, and upbringing. Besides that, driver behavior is governed by emotions, mental activities, and physical actions. So for the problem statement, this study came from these two problem statements. The first one is unrealistic measurement of vehicle fuel and emissions to represent aggressive driving. So based on this first problem, based on the previous studies, the measurement of aggressive driving is based on vehicle operating conditions and uncharacterized participants. So the characteristics of the participants were not clearly defined. The participants may or may not have aggressive driving characteristics. Hence, measuring fuel and emissions based on non-characterized participants, the data obtained does not represent the real characteristic of aggressive driver. The second point for the problem statement is based on the previous research also, other researchers had done with induced aggressive driving behavior via driving instructions. Participants need to follow the specific driving instructions. This means that the participants were forced to be aggressive in a non-natural way. So, based on these two problems, this project intends to assess the driver itself and the physical factors together. So, in order to obtain the realistic measurement of vehicle fuel and emissions, so we need to focus on the driver and physical factors. So, which is for the group of participants, we need to screen them and then to identify and then group them into the specific group, the aggressive group and the non-aggressive group. And then for the measurement methods, in order to measure the driving behavior, we use Onward driving assessment, ODA. And then in order to measure the fuel and tailpipe emissions, we do the experiments on the chassis dynamometer. So for the aim and objective for this study, the study aims to measure the impact of aggressive driving behavior on vehicle fuel consumption and tailpipe emissions. So this study has four objectives. The first one, to identify aggressive drivers using a self-reported assessment tools. The second objective, to observe anger expression and measure driving performance. The third objective, to develop draft cycle for simulation of vehicle fuel consumption and tailpipe emissions. And the last one, to measure the vehicle fuel consumption and tailpipe emissions result from actual aggressive driving behavior. So in order to achieve the specific objective, we make it or we work it in the specific phase. So phase 1 to cover the objective 1, phase 2 to cover objective 2, and so on. So the significance of this research, we have two significance. The first one, combination of assessment methods, which is we address physical and driver factors together. Then the second one, drive cycle development. So based on this study, we have developed a new non-legislative drive cycle based on real aggressive driving behavior to measure fuel and emissions. So for the research methodology for this study, is based on these four phases. The first one, identification of aggressive drivers, and then after complete with the phase 1, we do the phase 2, onward assessment of aggressive driving behaviors. For the third phase, drive cycle construction based on aggressive driving behaviors, and then the last phase, measuring vehicle fuel consumption and tailpipe emissions. So for the phase 1, in order to achieve the objective 1, the identification of aggressive drivers. So first, we need to define the location. So for this study, the location of this study, we decide to do it in Skudai Township. And then the instrument that will be used is that have been used is driving angle expression inventory. And then in order to determine the sample size is very important, as it is impossible to survey the entire population. So in this study, three approaches were used, consisting of Craigie and Morgan sampling method, Cockcrash formula, and G-Power software to ensure that the sample size was adequate and accurate. So based on this approach, we have the minimum sample is 129 by using G-Power approach, and then the maximum sample size is 389 by using Cockcrash formula. While for the participants were of different backgrounds and above 18 years of age, no monetary compensation or incentive was provided to the participants to respond. So the procedure for this phase 1, we have distribute 400 questionnaire randomly. Okay, and then the written questionnaire, we do the data analysis. So after complete the first phase, then we move to the second phase. But before that, this is the example of driving angle expression inventory. Okay, which is it consists of 49 items that are represented by 4 subscale. The verbal aggressive expression VAE, physical aggressive expression PAE, and vehicle aggressive expression VHAE, and constructive or adaptive expression CE. These DAX items are rated on a 4-point Likert scale ranging from 1 to 4 that indicate the different spectrum of aggressiveness, such as number 1 represent almost never aggressive, 2 sometimes aggressive, 3rd often aggressive, and 4th almost always aggressive. Okay, so once complete the first phase, so we move to the second phase. So for the location to be specific, we need to determine the specific route and put some place marks along the routes. And then for the participants, a total of 330 completed questionnaires were written with a response rate of 82.5%. The remaining questionnaires that were not written or incomplete are 70, that represent 17.5%. However, the number of complete questionnaire was deemed sufficient to meet the minimum sample size required for the data analysis. Several instruments were used in this study to measure and determine driving behaviors and driving performance during the ODA in this study, such as dashboard video camera, Android GPS logger, instrumented vehicle, and driving angle expression inventory DAX. During the on-road driving assessment, the ODA was only conducted during daylight weekdays, starting from Sunday to Thursday, as it is the working days in that location. Weekend and public holidays were not considered in this study because weekend and public holiday is the larger contributor to the traffic compared to weekdays. So, for the procedure, in general, the ODA was conducted in 5 months during daylight and good weather condition with 11 participants. The procedure to perform this assessment was classified into 2 categories, which is before ODA and during ODA. Pre-test drive have been performed by the participants before the real assessment took place. Participants were asked to study the route and test drive along the route at least 3 times in any traffic conditions. The reason was to let them be familiar with the routes. Since most participants stayed within the location of the study, the selected route was therefore known to most of them. Then this is the research route and place marks. As we can see here, the route which consists of the local, collector and ethereal routes with about 13 kilometer length that divide into 2 sections, interrupted, which is that represent the blue line, and non-interrupted section that represent the yellow line. The interrupted section represent 3.71 kilometer collector and local routes, which are mostly regulated by traffic lights. Meanwhile, the non-interrupted section consists of 9.29 kilometer ethereal roads with no external elements such as traffic lights that might interrupt traffic. So for the third phase, microstrip cycle construction has been used for constructing driving cycle for aggressive and non-aggressive driving patterns. Microstrip method is commonly used to construct a drive cycle due to its flexibility and simplicity. Then the driving pattern data have been collected and saved in GPS logger during ODA. So we have about 165 driving patterns that have been collected. Then we eliminate the idling period. So then the microtrip analysis we analyze by using a time average. The driving pattern is computed according to the time average at respective microtrips as to standardize the difference of arrival time among participants and to achieve the acceptable length of time per microtrips. Then we have drive cycles developed, which is 8 non-legislative drive cycles. After that drive cycles were analyzed by using kinematic assessment parameter and statistical analysis. So these are kinematic assessment parameter: time, average speed, maximum speed, average positive acceleration, average negative acceleration, and the last one, positive acceleration kinetic energy. So for the final stage, measuring vehicle fuel consumption and tailpipe emission, this phase was conducted at our university, to be specific, automotive laboratory. We use chassis dyno as the instrument in order to measure the performance, fuel consumption and emission of the dedicated vehicle by using the developed drive cycle. We use standard vehicle setup procedures, and then the data obtained were analyzed. So For the result for each phase that will be present later. Okay, this is the result for the first phase. Identify aggressive drivers. So 10.6% of participants, or equivalent to 35, were identified as aggressive, while 89.4% or 295 were non-aggressive. Verbal aggressive expression increased, while vehicle aggressive expression decreased among aggressive participants and vice versa. VAE is weakly correlated with gender among aggressive participants. VAE is higher. Verbal aggressive expression is higher in female, 21.93 compared to male, 15.38 among aggressive participants. Okay, this is the infographic. From 400 questionnaire randomly distributed, the written that we have 330 participants, and based on 330 written questionnaire, we group about 35 participants into the aggressive behavior. So as we can see, based on 35 aggressive behaviors, aggressive drivers, so we group into the specific category, gender, driving competency, and age, as we can see in this infographic. Okay, the result for the phase 2 on-road driving assessment, 10 out of 35 participants agreed to participate in on-road drive assessment, plus 1 we have choose from non-aggressive drivers to be considered as control sample. 70% and 60% of aggressive participants were offered aggressive in vehicle aggressive expression and verbal aggressive expression, while 20% of aggressive participants were sometimes aggressive in physical aggressive expression. Significant difference in car observer rating over self-rating of items in PAE. Significant correlation among items in negative subscale. Significant difference of driving performance between aggressive and non-aggressive participants were found in all traffic conditions. Aggressive participants showcase aggressive driving behavior, which is speeding, tailgating, dangerous overtaking, lane keeping violation, and traffic light violation during ODA, in contrast to CS. This is the example of aggressiveness of the driver. The first one is tailgating. As we can see at the upper left picture, the driver tailgating the slower vehicle in front of them, and then the picture at the lower left, the driver tailgating the heavy vehicle. The lower right, the driver tailgating for prolonged or longer period, and then the upper right, during the busy hours, the driver tailgating the car in front. And then this one is dangerous overtaking. As we can see at the left, the aborted dangerous overtaking. At the center, flying overtaking, and at the right, sudden accelerative overtaking. And then this is the violation. Picture at the left, the driver violate the traffic light, and then at the right, it's maintained for the lane keeping. Okay, for the result for phase 3, development of drive cycles, about 165 driving patterns were analyzed and developed into 8 non-legislative drive cycles for the estimation of vehicle fuel consumption and tailpipe emission. 2 types of drive cycles have been developed, aggressive drive cycle and non-aggressive drive cycle. AGDC, aggressive and non-aggressive, has different kinematic characteristics. Aggressive lies in cluster 2 with the previously developed drive cycles that have similar kinematic characteristics. So this is the drive cycles for the morning session. Okay, as we can see, for the aggressive drive cycle that have a shorter period, while the non-aggressive it took longer period, which is over 1000 seconds to complete the whole cycle. And then this is the drive cycle that have been developed for the afternoon for both aggressive and non-aggressive. And then this one, the drive cycle that have been developed at the evening test. Okay, as we can see, for the aggressive drive cycle for the morning, afternoon, and evening, they have a shorter period, lower than less than 1000 seconds as compared to non-aggressive, that all the non-aggressive drive cycle have longer period in order to complete the whole drive cycle, which is over than 1000 seconds. Then this is another one, that the combined drive cycle, which is drive cycle for morning, afternoon, and evening, that 3 drive cycles have been combined to become one aggressive, that we call it as combined aggressive drive cycle. And then at the below is non-aggressive drive cycle that combine. So the result for phase 4, measurement of vehicle fuel and tailpipe emission, total fuel consumption for aggressive is 16 liter, while non-aggressive is 20 liter. Increasing carbon monoxide and carbon dioxide emissions trend in aggressive and non-aggressive. The difference of carbon dioxide emission between aggressive and non-aggressive based on speed cluster is not more than 10%. The difference of carbon dioxide emission between aggressive and non-aggressive based on traffic condition were 3.34% for the morning, 2.85 in the afternoon, 3.46% in the evening, and 3.09 for the combined drive cycle. The difference of carbon dioxide emission between aggressive and non-aggressive based on road section is 4.17%. Carbon monoxide and carbon dioxide emission influenced by speed variation, traffic condition, road section, travel time, and average speed. So this is the result for the phase 4. As we can see, for the morning traffic, for the aggressive drive cycles, it consumes about 1.26 liter in order to complete the whole drive cycle for the morning traffic for aggressive. For the non-aggressive, it consumes 1.38 liter of fuel. Okay, this is the result for the afternoon session. As we can see, it just consumes about 1.51 liter fuel as compared to non-aggressive, it consumes 1.58 liter of fuel. For the evening traffic, again, aggressive drive cycle just consume 1.50 liter, while for the non-aggressive it consume a little bit more, 1.54 liter. And then for the traffic, combined traffic, okay, 1.24 liter of fuel that has been consumed for the aggressive, and then 2.14 liter of fuel that have been consumed in order to complete the non-aggressive drive cycles. Okay, this is the comparison between aggressive and non-aggressive for speed variations. Carbon monoxide trends increase with speed. High carbon monoxide in aggressive and low in non-aggressive. While for the carbon dioxide, trends increase with speed. Percentage of difference is less than 10%. This is the comparison for traffic conditions. Carbon monoxide, CO emission varies across traffic. High CO emission in the afternoon. And then for the carbon dioxide, CO2 emission highest in the afternoon traffic and lowest in the morning. Difference of CO2 emission in aggressive is 3.5% lower as compared to non-aggressive. So for the conclusion for this study, 35 out of 330 respondents were identified as aggressive, that consists of 21 male and 14 female. The result reveals that 65%, 58%, and only 18% of the vehicle, verbal, and physical aggression were expressed by participants in the real driving situation. Significant difference of driving performance between aggressive and non-aggressive participants were found in all traffic conditions. Weak to strong correlation among driving performance variables in aggressive participants. The study developed 8 new non-legislative drive cycles for the aggressive and non-aggressive drive cycle via microtrip analysis approach. Cluster analysis shown aggressive characteristic is comparable to the driving behavior in other populated cities and implies an act of aggressive driving behavior. Vehicle fuel and emission in this study were measured using simulated drive cycles derived from real participants. Aggressive drive cycle showed lower fuel consumption and tailpipe emission as compared to non-aggressive drive cycles. The length of non-aggressive drive cycles was found twice greater than aggressive drive cycle, explaining the higher fuel and emissions as compared to aggressive. Aggressive drive behavior had an impact on vehicle fuel and emissions. And the last one, length of drive cycle driving time had an impact to vehicle fuel and emissions. So that's all. Thank you for your time.